Well, thanks everyone for joining me for this talk. It's a privilege to be here and presenting. You can probably tell from my accent I'm not from here, from South Africa. So I work at a company called Chillisoft Solutions. We build bespoke software. And what I'm going to be talking about is ways to unlock existing data and understand how to layer graph analytics over that existing data. Some ways that we've been doing it. Really, it's a story about the things that we've learned along the way. Now, I like starting out I seem to have a habit of starting out presentations with landmarks from South Africa. So some of you might know this one. It's creatively called the Big Hole, or in Afrikaans, very colorfully called die Groot Gat. So it's basically it's a place in Kimberley which was a diamond where diamonds were discovered in 1870, and 50,000 people built this hole, dug this hole with shovels and pickaxes. And it took them 43 years to do that, and they dug to a depth of 200 meters. I wonder if you've heard the phrase, people don't want to buy a quarter-inch drill, they want to buy a quarter-inch hole. But I'd say that if you look at these guys who are working in this hole, I think they would have preferred you to have said they'd rather have the diamonds than have to actually have the hole. So I think there's more to it than just sort of finding the first problem to solve, the hole. Why do we want the hole? Is kind of more what we are about at Chillisoft. We try and understand what the problem is for our customers and then help them solve that problem. So to take this back to graphs, I would say people don't really want a graph, they want to be able to answer new questions. I'm finding in the work we do when we're building custom software for companies, and oftentimes those companies have software developers of their own. In our case, and this may not apply everywhere, but in our case, the appetite to take on a new core database type or new core database is not always there, especially among those companies that are not early adopters. And so what we've come up with is a way to use the power of graphs, but not switch over anything to graphs. So what we've had in the past is our quarter-inch drill has been the relational database management system, probably like many of you, or SQL database to be more accurate, actually. And those databases have limits to the types of things you can ask of them, right? They're great for aggregating, summing, for intersecting, or things you do with sets, but they're terrible for connectedness, centrality, components, degree, betweenness, and all the interesting things you can get out of graphs. So when one customer came and asked us, how are X and Y connected? We realized we didn't have the right sort of tool for this job. Our relational database wasn't going to cut it. And so we started exploring graphs, and this was about a year and a half ago. So we started exploring graphs and what we could do with that, but they didn't want to rebuild their systems on graphs. And so we looked at how can they unlock the data that they have. They have loads of operational data, and that data actually had the information that they needed. It just wasn't in the right form to be able to ask the systems of it, or the data mines, or the warehouses, or the marts. They didn't have the right data, the right structures to be able to do so. So what we did is we started embarking on extracting this data from all these SQL databases into one graph to be able to answer those kinds of questions, like how are X and Y connected, or who is the most influential person. So I'm going to quickly talk through our approach that we've taken, so the sort of broad overview of the approach, and then through modeling some ideas around what we've learned about modeling data that's in a relational database and a graph, and then around processing the data, so patterns that we've come up with, or the method that we've come up with for processing the data from relational database into the graph. And then finally, I'll do a demo of some software. In the process, we've built some software along the way, and I'll show you the software that we have built. The overall approach that I'm looking at is a way to layer a graph. In this case, it's Neo4j. Where you see graph, read Neo4j. What we're doing is taking the source data, processing it through a batch process, and generating a graph. From there, we've built some basic user interface capability for users to explore the graph. That user interface really could be things like a Cypher query that's automatically run to look for interesting patterns, or it could be an analytics engine such as SparkX, or it could be a basic user interface that the user can just browse around. This way of doing it allows you to use your existing data as it is, produce it into a graph, and start asking questions that you couldn't ask the source data. Why are we advocating this approach? Mainly because it's cheaper. It gives you the power of the graph. You can ask questions of the data that you have, but you don't have to redesign your systems on a new platform. And that costs a lot of money in whatever currency you use. So we're looking at doing it in a cheaper way, essentially, using the power of the graph for less cash. Okay, so for modeling a graph, some ideas around how to model this existing data that you have into a graph. And I've got some detailed examples, which I think I'm going to keep. I'll go through one slide of that, and the rest you can have a look on SlideShare for the actual detailed slides, because they're quite technical. But my thinking around modeling a graph is start with an idea of what you want to ask. If you may have a bunch of data. I mean, this is the case with the different companies we're working with in Durban. They have a lot of data, and they want to know what can they find out. What things can they find out that they couldn't find out before? And you might have an idea of what you could ask. So start with that idea, or just start with the idea of exploring. Maybe build the graph, and then you'll be able to explore. Then make the graph from your concept, explore the result, and then iterate. Emil showed us the Northwind database, and there was a blog post by Neo4j a while back on how to get that Northwind database into your Neo4j before they built the automated process, or the example. And in the way they've modeled that Northwind database, you can ask certain questions. But having got it into a graph, being able to explore it and then think about, maybe I should model it in a different way. Maybe I should model it like this. Then I could ask these other questions. So I think it's really important that you're able to iterate on the process of modeling your graph. Guidelines for modeling. The one that Neo4j, that blog post gave was generally one row equals one node. One row in your relational source is going to equal one node in your graph, but not always. It's not always true, because sometimes different tables, depending on how the system's been modeled, sometimes some tables are actually the same node. The same two rows, one row in one table, one row in the other, are actually the same node at heart. Or in some cases you don't want the node because it just clutters up the graph. Don't include your complex data. So we're pulling in data from a relational system. It sometimes has fields like comments or some XML fields. That stuff doesn't scale well into the graph in my experience, into Neo4j, especially when you're getting into the sort of tens of millions. Neo4j doesn't handle the complex data that well, and you can't do that much with it once it's in Neo4j, that kind of data. So we bring in sort of mainly the core data structures, or the core data that comes from that relational database. And what I found is to ensure I have a unique ID for each node type in my graph. I mean, it's similar to having a primary key for your relational database. Now often you can use the primary key, but depending on how your data is coming in, you might not be able to use that primary key. So we actually just create a new one. And we create, when we're doing it, we create a unique ID that's unique across the entire graph. So we use a big int for it, or 64-bit integer. So some examples, and this is where I'm only going to go through one particular example. In fact, let me switch to this one. Right, so most of us will be familiar with the tables on the left. Either if you've used a relational database or if you've used things like maybe Excel or any sort of other tabular data form. So there's a person table and there's a telephone number table. And the telephone number is related to the person through a foreign key. That's the person ID field is related to the ID field on the person. And so a person can have many telephone numbers. And these are generally what I would call value types in a relational database. The actual ID or the sort of unique identifier of the telephone number doesn't matter. It's the actual telephone number that matters. And so possible graph forms, I've actually got 4 possible graph forms, and there's probably many others. I've just picked out the sort of common ones. But a possible graph form here is to create a telephone number node for each row in our telephone number table. But if you look carefully, this telephone number here is actually the same as that telephone number there. So maybe that isn't actually a good idea. Maybe you should rather have just 2 telephone number nodes and only have the value and forget about the IDs. Or alternatively, and actually this is generally currently my favorite approach, and I think it totally depends on what you want to query in the graph, but just collapse all of it onto the node itself, the values, the telephone numbers. Why? Well, there's a number of reasons, but it's mainly to do with how you're going to query this data, and that's why I've got the 4 possible graph forms. I mean, you're not going to always know up front exactly how you're going to be querying the data and let me stand this side. And what answers you're looking for, what questions you want to ask. So you might need to play around with the different modeling forms before you settle on one. Another interesting one is the many-to-many, so the sort of associative tables in relational databases. I've got a person, a role, and a person-role table there. And you can see in this case, I've actually got data on this associative table. And that there, the delete permission field is an extra piece of data on the associative table. So what we can do is we can pull that data into the relationship itself. And it becomes simpler than the original form. Much simpler, in my opinion. Okay, so those are some modeling forms. What we learned in the process was we had to have a way to be able to model things differently and try the new approach. So create some rules around how the modeling was going to happen and then rerun our modeling rules. Because we found that the initial idea we had was wrong or didn't answer the right questions, or the user's experience of exploring this was just, there was too much information. So what we found was we needed ways to process the data again and again and again and adjust the rules along the way. So in my opinion, if you're going to be processing data from another store into a graph, automate that process as much as you can. Don't dump it out into CSV and then write some Cypher. Well, you could dump it out into CSV and write some Cypher, but try and automate the whole process, or automate pieces of the process along the way. And also start with a small data set. You want to iterate quickly around a small data set and get a sense of how that looks before you roll it out to your full data set. check the results. So that's definitely, look at what the output of that is. Look at what the graph looks like. Does it make sense to your users or to a business user? And that's another thing that I didn't include here, but the business user, if I'm a developer, the business user is the one that really needs to be able to make sense of my graph model. And then two things that really sort of impacted on our experience was we needed to bring multiple data sources together into one graph. And secondly, do I need to track changes over time? And actually, we haven't solved that yet. We've done some work on it, but we haven't got the sort of time-lapse changes in the graph correct yet or working. But that is something that adds complexity. So here's a diagram of our what we've built along the way. Is we essentially we're taking multiple data sources, Oracle databases and some Excel data, and possibly some other sources. We're taking those and we're building out an event stream. So out of multiple data sources, unify everything into one event stream. And basically each row from our source data is coming in as an event stream. Sorry, an event into the stream. We're saving that event, and we're just saving it into a SQL database at the moment. But that unified event stream then becomes our actual source data. Then if changes come in later into the source data, we simply add new rows to indicate the updates. The second part of the process is to take that event stream and process it, and basically match events together. So there's a process that goes through the whole event stream and finds the matches between different events. And that builds out this enriched event stream, which includes at the bottom a match lookup table. So really it's a lookup table to say that this ID actually is equal to that ID. And then the third phase is to filter out what we're interested in, and then project our set of rules, project that, and we actually pump out a bunch of CSV files at that point. So CSV and .cipher files. And then finally, we run those in sequential order to get everything into a graph. So I'll show you a demo quickly of this process. This is my small database. It's 4 tables. There's a couple self-referencing tables and a few foreign keys. I've only got about 20 pieces of data in this database, but it's indicative of a data structure that we've been working with. Okay, so if I run, I've extracted the data out into CSV files, and I'm going to run a simple batch program that essentially pumps out the CSV files and then starts running those CSV files against the Neo4j shell using the CSV bulk import API. So it ran, if I can show you the files quickly, that it produced in the process. Okay, let me show that on the screen. It produced this set of cipher and CSV files. It orders the cipher into creating node types, which was really just creating indexes, then creating the nodes, which is these ones, and then creating the relationships, which is all these. So it sort of bulks everything together and runs them as separate imports. And now, I mentioned providing users with a way of viewing the data so that they can kind of validate your modeling. So we've built a very simple interface where I can search for my data that I've imported. I've searched for my name, I'm a customer, and then I'm able to view the relationships and then visualize those relationships fairly easily and browse around. So I can start kind of understanding how this data has been modeled into my graph. If you look on this person here, you'll see we've stored some things as documents. I mentioned not pulling our complex data into the graph. So we've actually taken all the data that's in our SQL database. And for each row, we've created a document and stored that in a search engine called Elasticsearch. And then we've linked that to the node in the graph. So on the node, there's a document ID, essentially, that links back to Elasticsearch. So I've actually stored, in this case, the policy I brought on as a document on top of the person node. But I might decide, actually, I don't want to see it like that. I want to see the policies this person has as a relationship. And actually, in the first case, what I did first was I modeled it as a node, and we found there was just too many policies, and they weren't actually that interesting to the business user. So that's why I ended up putting them on as a document. But I can switch back by adjusting my rules. And I'm just going to run the second example. It's popped up on the screen. So it's processing again with a slightly different set of rules. And if I open up my browser again and search for, I'm just going to search for Peter again now, this policy has shown up as a relationship, and it's actually a relationship in the graph. And if I view that graph, the policy is showing up as a node. So what we found was this was essential to really modeling stuff into a graph, is to do it and then show users, have a look at what had come out, and then help them decide, make decisions about what questions do I want to ask of this? How do I want to explore this data? Is this the way I want to do it, or do I want to rather have, let's say this person had 5 policies, would I want to see all of them around the person, or would I just want to see them listed as documents instead? So, in summary, getting your data into a graph, your relational data into a graph, helps you to answer new questions and to find new questions that you could ask of your data. And rapidly iterating that helps lead to new discoveries. And this is why we like the idea of this event stream, which you can reprocess over and over and over with new rules to create a new graph. And we found the interactive graph user interface allows business users to really see the data. That's it for my core presentation. Thank you. Thanks very much. We're done.